Hello everyone, in this video we're gonna build a little game for babies. Wait, what? Yeah, inspired for my kids playing with a baby sorting toy, I said, it is possible to build a game like that in iOS? Dragging objects from one place to another? Absolutely! And why not using SwiftUI for that? This is going to be fun. My name is Pete, and this is SwiftUI Tips. Couple of things before starting. I want to focus on functionality first. Later, we will sharpen the UI. Said that, we will represent the shape holes with circles of different colors. We will move a draggable object, that is another circle, to the circle having the same color. To do that, we need to check if the two objects are colliding. If that's the case, we did it right and move to the next challenge. Otherwise, the draggable object will return to the original position. If you drag the object correctly 3 times, you win the game. It's that simple, because it's for babies. The second thing I want to talk is that I won't cover all the details of drag gesture here. I made a video for that is in the description below or appearing in your screen right now. But don't worry, you can watch it after this one. So, let's get started. First, let's set up the project to only support iPadOS 15 and above. We will support iPad only for now, and later bring other devices. Now, let's create a toy model. It will be a simple struct with 2 properties, a color that will appear in the screen, and an ID to match the draggable object to the container. In this case, let's represent the ID as a simple int. Let's create a sample array for all the toy containers in the screen. Okay, now let's create our main view called Baby Toy View and remove Content View. Here we will build the whole UI for our game. Now the next thing is to bring those objects in the screen. Let's start with our draggable object and create a new file for it. Let's call it DraggableToy. We will use a circle to represent this object in the screen. Let's use a red circle shape with a square frame of 100 points. Cool, the object is there. By the way, let's keep the code away from magic numbers and use a property to manipulate the size easier. Now, what about the position? We don't want to control that here. We want to delegate that to another object. We will create 2 new properties, one to provide the current position and another to provide the gesture. Without a gesture, we cannot drag the object anywhere. We have a problem here. As we saw in the drag gesture video, gesture is a protocol pretty similar to view protocol. Both contain associated types. And we will get this annoying error that you might see already working in iOS. I talked more in detail about this issue in my video, Protocols with Associated Types, that is in the description. Let's fix this really quick. The error is self-explanatory. You cannot use this protocol directly, but has a generic constraint. Let's create a generic to conform gesture protocol. Boom, the issue is gone. And the great thing is that any kind of gesture can fit here, not only drag gesture. This is cool. Lastly, for draggable toy, let's add a toy object that will be represented in this view. The toy will provide the color too. Very nice, the draggable toy is ready. Let's add it to Baby Toy View. Now to keep code cleaner, let's move drag gesture to a dedicated computer property. This is fine, but we could erase the gesture type using an opaque type instead. And still compiling. Cool, let's now add unchanged and unended modifiers to drag gesture and capture the current location of the draggable toy. We finally drag the object around the screen. Nice. Now it's time to add the toy containers in the screen. Let's use a lazy big grid to build a grid of 3 columns and place the containers there. The logical choice is to add a base tag to keep the containers at the top and the draggable toy at the bottom. Let's do that. I'm using those blue circles as a placeholder. We will fix this in a moment. What I want to check is if we need more spacing between rows. Looks like yes. Let's add a spacing of 100 points. Looks better. Now you are seeing that draggable toy change its position. Technically, this is okay. Position is relative to the stack container. Actually, this is the main problem of this application, finding and saving all the positions of those views. Do you have an idea how to do it? In UIKit, it's pretty intuitive. You just need to get the views frame in build load and you are good to go. If you are new in SwiftUI, you may be stuck here for a while. The only way to get the current position of a view is using Geometry Reader. In fact, we worked with Geometry Reader in a previous video to make the Apple Watch layout. This is the tool to make a more flexible work with the views in SwiftUI. Now, here comes another problem. We need to be careful about the coordinate space we want to use. There are global and local coordinates. Globals are great to detect the collision because everything is relative to the screen. However, it's harder to position the draggable object dynamically for all kinds of screens. Also, we will have to move everything to a Z-stack. On the other hand, with local coordinates, it's easier to keep the track of the draggable toy and set coordinates dynamically for all screens, keeping everything in B-stacks like we are doing right now. The problem is to figure out where are the toy containers and the collisions. I spent many days thinking the trade-off. And at the end, I found that keeping everything in a Z-stack works better, at least for now. Said that, we will put all the objects in a single Z-stack to track everything in a single space. Let's create a new file, toy container. As I said before, we need to use Geometry Reader to get the current location of this view. The question is where to add it. We could just wrap the whole view with it. This is cool, but I found a better idea. Let's use Overlay modifier. Overlay will add an extra layer for our composite view without wrapping everything in an inner closure. Cool, right? Now we can use proxy to get the current frame and save mid-X and mid-Y. The thing is that we cannot use state property. Do you know why? That's because state property will render your view again every time you update it. In this example, we will produce an infinite loop and undefined behaviors because the state is mutated in the middle of the render. We don't want that. By the way, I added an empty color as a placeholder layer to satisfy this view builder closure because we are adding code that is not a view. What we need here is storing the positions without triggering view updates. Observable objects are great for this. Let's create a toy view model to persist the toy container frame using an observable object. Let's create a dictionary with an int key representing the container ID and a cgrec to store the frame. Let's add a method to update the ID and the frame. Let's go back to the container and call this method. We need to pass an observed object as a parameter and a toy object representing the ID and color to match. Let's update the color and update the frame size with a variable. Cool, it's time to update the for each in BabyToy View with the toy containers. But first, let's create a variable to represent them in the view model. Let's create a property for view model in BabyToy View. And since this is the root view, let's add state object property wrapper. Don't forget to fix the toy container preview. Nice! We are moving forward. Now it's time to fix the position of the draggable object. Let's move position and current toy from the view to the view mode. We need another method to update the position. Let's create another function in the view model too. Now let's call this method on the drag gesture events. It's compiling, but we cannot drag the draggable toy. We need to use published property wrapper to update the view every time we got a change in the position. Let's go back to the view model. Nice, it's working again. Lastly, for the draggable toy, we need to set the initial position. It was really hard for me to find out that value to position the view correctly. This is the drawback of using C-stack over default position of B-stack. My only option is to use UI screen.main.bounce and use the midpoint with a little offset as the initial position. Let's try that. Not bad. The object is now in the center of x-axis, but at the bottom of y-axis. However, this proposal is not scalable because if we rotate the screen, we need to recalculate the initial position. Otherwise, this will happen. If you find a better idea, please let me know in the comments. Okay, we need now to reset the position if we end the tracking. Let's create another function to send that state to the view model. Cool, the toy is reset if we end the dragging. It's time to work in the business logic for the game. We need to detect the collision between DraggableToy and any of the containers. And if we end the dragging, checking if we are in the right color. Let's first work detecting the collisions. That should happen during the dragging. Then we need to go to update drag location function. To simplify the work, let's detect if we are colliding with container number 1. We need to check if the frame coordinates are touching the drag location, but with some threshold to not being pixel perfect. By the way, the 50 is the distance between the radius to the edge. Looks like this code works, but it's super verbose. It can be better. There is a function in cgreg called contains that do all the previous work for you. Isn't that cool? Now that we know that collisions are detected, let's update this code for the rest of containers. The print message works well, but it's hard to see that in the app. We need to provide feedback to the user when it's over a container. For that, we need to know which is the highlighted ID. With this information, we can now highlight the right container. Let's go to ToyContainer and add a feedback in the screen. We will add another circle at front with a low opacity but a higher dimensions to make that effect. The highlight is there, but we got two issues. The first one is that frames in the first row change when we highlight a view. And the other problem is that if we end the dragging inside a container, it keeps the highlighted effect. Let's fix the first issue. We just need to fix the frames. Nice. That was easy. Now let's fix the highlight. Let's go to the view model. This is not a bug yet. This is part of the implementation. We need to figure out what to do when the user releases the object over the toy container. That will happen in confirm drop function. To fix the current problem, we simply need to reset the highlighted ID to nil. It works, but now I got something else. It's hard to see the draggable object. Let's fix that adding a shadow. Not bad. Let's back to the view model to add the rest of confirm drop. we want to check if the last position after the end of dragging is correct or not. We have highlighted ID for that. First off, whatever is the result, we will have to set highlighted to nil. This is a great opportunity to use defer. Defer will execute that line until the end of the function. You don't have to worry about this tag anymore. It will be executed as a last step. For now, let's comment reset position. We will bring it back in a moment. We need to check if there is a highlighted ID value. Otherwise, we can't continue and we need to restore the position to the default state. Alright, we got the ID. We have to check if this ID is equal to the current toy.id. Let's code the else case first. If this is not the right ID, we need to reset the position here too. We just have to check the correct path now. In this case, we want to make an effect of disappearing for the draggable toy. We will reduce the opacity and also change the current position to the container's position. Let's create an opacity property for the draggable toy. By default will be 1.0. We will change it to 0 when we add it to the right container. Now add that value to the view using the opacity modifier. We're almost done. Let's assign the container's position to the draggable toy's position. Very nice. Let's run this. Excellent. Draggable toy disappeared. But everything happens without animation. Let's add a more fluent transition. Let's go to drag gesture and wrap confirm drop in a with animation function. And run again. Great. We can see now the animations. Hooray! Finally, we need to add a game state to restore everything again. And also, we are just testing with the same draggable toy and containers. We want to add a more challenge and also play it with more than one draggable toy. Let's add then a round of 3 draggable toys. Shuffle the containers every round and restart the game once we finish the 3 rounds. Let's add more toys then. An array of random 3 toys and shuffle the containers. Now let's create a function to set up the game the first time. We need to make current toy an optional. When we got current toy equal nil, that will mean we end the 3 rounds and the game. We get the first toy in the arrays of toys. Let's go to baby toy view and add setup game when view appears. Let's go back to view model and fix the issues. Okay, project is compiling. Now, once we got the right answer, we need to move forward to the next round. Let's create a function for that. Let's get a new toy from the array and confirm if current toy has a valid toy, or otherwise we end the game. Let's shuffle the containers and set up the toy for the next round in prepare objects function. Don't forget to restore the opacity. Now let's add the logic for game over. Simple, add an alert to say that you won the game. Why not adding the number of attempts? Cool, now before running the app again, let's call next round function in confirm drop. Let's try out. I think it works well, but we don't want to see the animation returning to the default state. We want to just disappear and appear directly in the bottom of the screen. Let's fix the animations on Prepare Objects function. Let's remove the animation for reset position, but keep it for draggable toy opacity. It's better, but you can see that previous color is still transitioning to the new one, and that's weird. We're going to leave it for now and fix that in a coming video. Don't forget to add the alert to say that the game is over. Let's try again. Very nice. Finally, we need to start a new game after pressing OK. Let's create a function for that. New toys will be shuffled again. Let's reset the attempts to 0 and call next round again to start the game. Now let's call this function when we press OK in the alert. Let's run this one more time. And I'm going to fail on purpose. There you go. The number of attempts is 5 and you won the game. The game is functional, and once we press OK in the alert, we start a new game. Oh, but the containers shuffle without any animation. Let's add it directly here. Let's try again. And let's press OK. Excellent! We have this baby sorting toy game made in SwiftUI. Alright, the game is working, but let's do a final test with my kids playing it to see what happened. Vas a mover el colorcito a donde va. Muévelo. Allá donde va. ¿A dónde va? ¿Listo? Suéltalo. Suéltalo. Pero suéltalo ahí en el medio. Y suéltalo.
One eternity later.
¿Dónde va el verde?
¿Por qué
Suéltalo, hijo. Así, mira, suéltalo así. Así. Listo. Ahora, el otro. ¿Qué color es? ¿Dónde va?
Aquí.
Muy bien. A ver. Suéltalo. Suéltalo. Así. Suéltalo. Muy bien. ¿El que sigue?
Aquí.
Muy
Está
bien.
cojo.
Ajá. Suéltalo. There you have it. Test succeeded. I hope that you learned something new today. This video cost a lot of effort. Don't forget your like, subscribe, and share with your folks. I would really appreciate it. If you want to learn more about SwiftUI, check out this playlist here. That's all for me, everyone. Thank you so much and have a great day.